Hi, I'm Mark Silverstein. Let me introduce to you the DSX500 microscope. Quickly, it's similar to a compound microscope in terms of magnification, but unlike a compound microscope where you're looking at a lot of separate or individual pieces, this is a complete unit with a lot of functionality built into it that you might see as optional or different pieces that you would need to add on to a traditional compound microscope. In addition, we're running it all through a computer system. No eyepieces as we've had before. Everything visually, all the controls from the microscope are controlled by the computer screen. So here we're looking at a PCB board. We have a very quick map image, so as we zoom out on our sample, we can see the larger area and we can see specifically where we are on the sample. This is a 3D microscope, so we could quickly take a scan of this image in 3D. And what the microscope is doing is it is going through a Z-height movements and it's taking images at different heights. So quickly what we see is an all-in-focus image where we're seeing both the background, the top of that resistor component on the board, all in focus. We can look at that image also in 3D. And quickly here, this is a little exaggerated, but we're seeing that height data off the board, so we really get a feeling for that height. When we jump over to our measurement phase with this same image, here we have the opportunity again. We're looking at that sample in 3D, and we're doing measurements in this mode across a profile line. So we draw a line across the specimen so we know where we're taking that measurement. We can move this to any point on the sample, so to get a different feel, to do measurements in different points or locations as we need to. We can see here on the histogram that we're measuring from the top of the sample to a height down on the board. And we can see our height measurement, in this case it's 778 microns. We could also simply go from edge to edge of our sample and very quickly look at the width, 750 microns of the sample. Step height is another quick measurement that can be done. And here what we could do is average the height of the component to the height of the board. So I can pick a region on the board and get an average height here and compare that to an average height on the circuit board. So this day we're not measuring just one point, but we're averaging both areas to come up with a height, an overall height between the board height and the top of that resistor. Geometric measurements are also available on the sample, and these are very simple point-to-point measurements. We can do a parallel line to help us make sure that we have it straight across that image. We have opportunities to do angles. And here we're getting an angle measurement of that sample. All of this data that we've collected, we can export over to a spreadsheet. In our report phase, we can quickly see the measurement that was taken. We can see the data from that measurement. We can alter that data if we want. So if we prefer to look at the 3D view of that sample, we can simply change it and show a different view of that sample to put together a quick report. With comment fields and templates, we can customize this report to match your needs.